So we basically covered there are two ways that this machine can operate. One of them is just a straight diode, which takes a long time to charge, but it's a charge that's dense. That's the radiant charge. The capacitive charge is more like a current charge in pulses. And so it stair steps the battery up. All right, so the question comes up, how can I get more out of the machine? And there's one or two ways to do this. You know, you've got this amount in this branch, and it's being triggered by this, so this is the actual circuit, so this is not a slave. All right? So to turn this around so that now there's another transistor and another transistor, Frank brought up a good question at lunch, that if you run too many transistors out there, you won't be able to drive them. You have no driver to drive them except for what's coming out of this circuit here, which is the trigger. I'm running 7 devices on this machine, and that's about the maximum that you can drive with this machine and turn them on and off. So the question is, if you can only use 7 devices, right? So I'm just going to do it with these 3 coils because I just run out of room. And all these are going to the same hot spot. Then you have 3 coils firing, which means that you no longer have this, but you start to get where you see that it's more and more and more and more and more. So if you have 3 of these running and then you got 21 magnets going around the wheel, you can see you're collecting a lot. About 2 times more, 3 times more. But you must, on each one of these circuits, and this is nothing more than what's done in amplifiers, you must balance these. They got to be matched. One can't draw more current than the other, so you have to very closely match them. And each one then has a base resistor. You want to be as close as possible on this coil. That's your load. Then you want to make sure that each base is receiving the exact same voltage. And I want to see 0.1 over here, and 0.7 over here, and 0.10 over here. If it's going to be 0.10, then they're all 0.10. And that's, and I don't want to see 225 volts here in the spike and 255 on this one and 400 on this one. Then it tells me that you've done something wrong. You haven't measured out each one exactly. You just took it for granted that you could twist some wire together and just roll it on the roll. You can't do that. So if you're going to build a machine, then the machine must be exact. If it's not exact, it's not going to operate properly. And you're going to get results. And if you go on YouTube, you can watch everybody with machines, and it's their opinion of the machine. It's not mine. Everybody's an expert except for the guy that made the machine. All right, so the other thing, the other question that was brought up, I want to address it right now, is neomagnets. Why does John not want any neomagnets? Why? Because first to play, the magnet's wrong for the machine, hard to adjust, saturates the iron, takes more power to release it and to make it go. And you can see this in an example of all the machines that are built out there. To get this coil to release, instead of the appropriate resistance on the base of 470 ohms, you're going to find 10. There's two things to look for. 10 ohms, because they can't drive the current through the coil to get rid of the neomagnet. Neomagnet will not leave. Now, when you do this, you are exceeding, and I want you to understand this, you're exceeding the SOA curve of the transistor. What is that, right? Yeah, right. Safe operating area of the device. So how am I looking at the safe operating area of the device? Here's the current. See the current? So it's just 5 amps. Here's the voltage. Well, how much voltage have you guys seen coming off the machine? The MJL 21194 is not rated for that. It's not rated for that. So what happens for a brief moment in time is the voltage is out here at 400 volts. How much can I have? 1/10 of an amp. You must understand this first, that you want to keep the machine at a safe voltage. First of all, it is not required to have on the machine 450 volts. It's only required to double the battery voltage. And that's it. Now, at that safe operating level, at 24 volts, how much current can I have? Maximum. Right, 16 amps per device. Why, Frank? Because you found out, didn't you? The first time hooked up, explosion, vaporized. Also, very important, do not disconnect the machine from the load if you're operating in this mode, which is the normal SG mode, because there's no load. So this is going to go real high. And this is going to fall on its face down here. Very simple. If you don't know it, go look it up. But don't blame John, because John is not there to say, oh, did you look at the curves for this device? Did you look at the curves for this? Because I'm going to be a sticker when it comes to this. This is done in all audio. Very important that an audio amplifier cut 1 amp at DC. Why do you think that is? Second emitter breakdown, when the speaker collapses. And you vaporize the transistors if you don't do that. So anyway, we know now 2 modes of operation, correct? We know the comparator, the capacitor charge, and discharge, and we know the radiant portion of it. However, the SG is very tricky, because if you do this properly, you can force the battery to charge, not deplete the primary. And when I mean force the battery to charge, I mean current. If you take the SG and you take this and you run it to the secondary battery, like this, what do you have? You have a generator. You have a real generator. And this is not going to drag. See, you just tricked the whole system. What's the problem here, guys? What did John originally want to do?
Get a motor, run a generator, and get extra energy.
Without depleting the front battery, right?
Which side of the battery is it positive?
Well, you can see that if you know what the diode is. It's plus, it's minus. So now we're using this as a generator. Now, the other important thing is if you get any heat at this transistor, the efficiency of the transistor is going to go downward. And it's going to go downward like this. As the device gets hotter, it's less and less and less and less. So, theoretically, and in all practicality, you would want this device running at room temperature where you could touch it. And you're the most efficient. Now, who really cares about COP if the back battery got charged long before the front one depleted? What?
Why don't you want this thing to work at its maximum?
It is working at its maximum. It's working exactly as I designed the machine.
So you're not using a capacitor discharge anymore onto the battery in that circuit at all?
No, I just said it was a generator. That this machine is capable of being 3 machines. The first machine is a radiant charger, which is going to take you a long time, and you better calculate everything out, and everything must be balanced for you not to deplete the primary battery. You should be able to get out of the primary battery 2 other batteries over there charged before this is at its 12-volt limit or 11-volt limit. And it'll run down to 10.5. Not good for it, but it will keep charging even at 10.5. Why? Because it uses the inductor. So, do we understand the basic operations of the machine and what the invention is? The invention is motor, generator. Now, if you think I'm kidding around, all the new Honda generators operate exactly on that principle. But they're using gas to turn them. Well, I'm not using any gas here. I'm using this chemical in the battery. So the invention in the patents is exactly what? It's a motor generator. And in the patent, how is it depicted? First of all, there are some very simple words in the patent. Those skilled in the art. Great term. Those skilled in the art. Okay, so, right, you use them all the time. Those skilled in the art may participate in this program of trying to copy something. You may participate and try to copy it. So therefore, when it doesn't work when you copy it, you're not very skilled in that art. You've made a big mistake. You shouldn't be making it. Anyway, let's get on with this. I want to go over this one more time. I don't want to see any neomagnets. I never said that I wanted to use neomagnets in the patent. I never said that at all. I said ferrite. And I said ferrite for the simple reason that I do not want to completely saturate this when the magnet's sitting on top of it. The major problem in the machine was also brought to my attention is the iron. The delay in the iron. How fast can it go and at what frequency level before you get this loss? Look guys, this is simple physics. A combustion engine works the same way. It goes to a certain point and then it loses. No longer do you have any more energy. It's simple physics. You can't break the laws of physics here. There's no way to break that law. There are, but I don't know them. And don't care to know them. I only care that you understand what this machine is and how you operate with the machine. Because there's far too many people that buy machines at people that produce kits, right? And they don't get the results. Why don't they get the results? They're not skilled in the art. They assume. Here's exactly the way they assume. First assumption. I don't need that transistor. I only need this transistor. However, they're forgetting to look at the SOA chart. Why did John choose that transistor? Because I looked at that chart. The next assumption is, oh, this shouldn't be 470 ohms. I like 1.2K or 1.1K better. And I don't like the diode he used. So now I'm going to put this one here that nobody's ever heard of. Each one of these parts has its own curves. So now, are we on the same page with the machine? Don't assume. Look up things. Don't put a post up there and say, can we use 355 feet of wire? Don't even bother asking me the question because I'm never going to answer it. I'm just going to ignore it.
I'll answer it. I'll say no.
Well, these guys will because they run the forum. We see these things all day long. But does anyone really understand how the machine operates? No. But you do now. You know what its three modes of operation are. If you want a slow, dense charge, make sure the primary system can handle what it needs to handle. Because this guy right here in the front, that's not efficient. What's efficient is what happens in the battery and what happens to the chemical. Now, you want an explanation about why that happens? Why do batteries restore themselves? Batteries are funny creatures. And for somebody to really understand a battery, go buy this book and build the battery in it. And once you build the battery, then you will understand exactly what's going on in that battery. Because you'll be able to watch it through the plastic or the glass. So you can't see what's going on in this battery right now. You can only assume. But when a battery that's badly sulfated has very little passages for the electrolyte to go through, so therefore you have no capacity in the battery. So what I have here is I have a window. And I'm looking through that window. Right now the window's pretty clear, right? But what happens when the window starts to get fogged up? It's hard to see through the window till the window cleaner comes. And he takes away all this stuff, and now you have a view in that one, and you have a view and a view. Pretty soon you're looking through the window again. So the idea is to generate a pulse that chips away at this like a little hammer. And when you chip this away, more electrolyte gets to the plates, and guess what? All of a sudden, you're saying to yourself, I rejuvenated the battery. And you did. And as long as you keep the battery maintained, you may have service life out of the battery. Don't put a battery on the machine that's got shorted plates, because you're never going to rejuvenate it. You're never going to get anything back. There's a little space underneath the plates. They're like little troughs. And it's a time for you. It tells the manufacturer how much time before that guy has to buy another battery. Now, people have tricked it and put them on shaker tables and put water in them and shook them and got the lead that's in the bottom out, but that doesn't say anything about the loss on the plates. It just says that you stopped the short. If you don't have any red lead on the plates left, you don't have a battery. And you're never gonna have one. All right, so now that we understand each other about the 3 modes of operation on the machine, so let's watch those modes here. Okay, first thing to do is look at the battery and pull some current out of the battery. You all been taking pictures of this. Basically what this is, and I'm going to do some recapping after I run it for you and show you, because I'm going to run out of time and the next guy's got to be here. So this coil is wound counterclockwise, all right, which makes the motor in attraction. So when these turn on, this is being attracted in. But like everybody knows in an attraction motor, that you only have half the pole that you can utilize with the magnet. So you can only use half. So the magnet comes in, attracts in halfway, and then it becomes neutral. And so the flywheel effect is going to carry it back around, right? And then at the next pulse, when the magnet goes by, it turns on in the field, and then it attracts in and it catches the second magnet. So the first magnet's totally useless on the machine. There's 21 of them on the wheel. So okay, the first thing to do is, if we're going to call this our secondary battery, then we're going to take the power from the secondary battery and we're going to watch what the primary battery does. Okay, see, they're saying 13.2 volts, 6 cells. Okay, so okay, we'll go with it. At 1 amp, 1 test amp, and we're going to start it and see where it is. All right. So here we go, and we'll run this really quick so that you can see how it charges, then how it comes back up and puts it back in, and then we'll take it back out again in these 3 modes. So the first little test will be the normal SG mode, radiant. So it's at 1 amp, it's pulling it down, it's at 12.35. However, storage batteries are funny. Sometimes they have to be loaded before the game. It would take us hours to do this, so I'm going to make short little tests so you can see exactly what the curves do. And then you can actually bring them out or do the test yourself. Now see, it's starting to find somewhere that it wants to stay. Okay, so we'll take it to here. And we'll stop the test. And I'm not going to save it because it's going to be on camera, so it's there. Okay, so this thing, so now we're going to go back again, go back to the same battery, and this time we're going to watch the charge. There we are. We're drawing a curve in the red. Okay. Okay, this is this charge. God, I hope I don't have to go this, unplug that and plug it back in each time. So that's this charge. Okay. And the motor's in attraction, so normally everybody says the transistors are heating by now with the machines that they're building, right? Well, I can guarantee you that these are not heating, and neither is the coil. So if you do not believe me, walk up here and touch the transistor. So you can see how the radiant charges it. We're going to watch it there. Nowhere near charged, right? So to see this, all you have to do is to calculate out what the machine's doing. All you have to do is a short little test. Draw the battery down at 1 amp hour. Get all the charge that was there out of it. Let it sit for a minute or so like we did. And then you can see here that we took, even in this short period of time, we took quite a bit out of the battery. Because now it's time, isn't it? It's time to charge. It's not very fast, is it? Approximately at 14.80, the battery is boiling, starting to boil. That's when the battery is going to start to gas. At that point, from that point on, you can only put so much more in the chemical, and then you're going to gas off the battery, you're going to lose electrolyte. Right. So this is the way an SG machine should absolutely charge. Now when I get it up to 15 volts, when it goes over the thing, I'll take the amp hour out of it again for that amount of time. And then I'll put it into generator mode and show you what the difference is. This one is what you call desulfation. So it's starting to curve over, right? Which means that if you look in the battery, it's boiling. But it's micro boiling with no heat because there's no real current there. So actually, if you look at it, the curve is just a little bit above 15, right? Okay, so this battery is sitting at 12.23 under load. Well, it was. Nobody ever touches these batteries at the shop. They just sit there. So I just grabbed them and said, have at it, John. But you can see basically what the curve is. It can only flatten off now, maybe raise a little bit more, and eat up the electrolyte in the battery. So if we stop, we got a good idea of what that is, right? Or does everybody want to make it go longer? It's up to you guys. Okay, so let's go back and do the same thing again. If I can make this thing work. Okay, so here the battery is at rest now, and we see where it rests. See, normally lead acid batteries don't rest there, they rest at 6.2. So this charge takes a longer time and is more dense because it's taking a longer time, so it's doing it very slowly. Okay. So does everybody see that now? Yeah. Okay. Okay, so let's no, it's going. Well, I've never ran it on this computer. I run an XP computer, which doesn't give me the same trouble as this. This is the new one, the 7. Okay, now, do any of you have a good memory? Okay, notice what it's doing. It's got a different curve on the discharge.
Got a load on it?
1 ampere. Absolutely right. It was a more dense charge. It's got a different slope, doesn't it? It'll all be on the camera, so I don't have to worry about it here. So actually, I'm able to take it out longer in time this time before I reach the same level. Did I gain any energy? Yes or no? Yes. Okay, so I've taken it out longer now at the 1 amp. And now what I'm going to do is just stop the test. I guess go up here and learn how to use this thing. Stop test. And then what I want to do is I want to go to a new test, right? New graph. Well, look at that. You just need to learn how to use it. Yeah. Well, I'm not computer savvy. In fact, I hate the computer. Okay, so now, remember I gave you this mode. I said that the SG was capable of being a generator. Forced mode. It's forced to charge because it's a generator. There is no pulse, there's no little spike, there's no capacitive discharge. It's just a straight generator. It's there. It's there. It's not going very fast. It's accelerating upward. It's doing exactly like a generator does. Just running it as a generator.
Will the fan blades keep it going too fast?
Well, they slow it down a little bit. I mean, it's blowing quite a bit of air over here because it's two fans.
Does the load help the charging of the battery in any way?
It's just in a generator mode. It can't do anything but operate like a generator.
Can I clap?
Yeah.
I did that, but it's not, mine's not balanced like that. With all the transistors.
Well, if I want you to see something, it's drawing a lot of current. It's drawing about 3 amps. Now, one at a time, come up here and touch the transistors. No, they're not hot. They are room temperature.
So John, at the beginning you did it. And back at the beginning, when you wanted to make that thing run in a circle.
That's exactly right.
There it is.
Okay. Well, this is the principle of the Watson machine, except that it just is using mechanical switching. This is using electrical switching.
So the primary battery.
Watch the battery.
Going up.
Primary battery is charging on.
Now, what's that curve compared to the other one? Quite a bit of difference. That's forcing the battery to charge as if it had a DC generator on it, and the DC generator can only put out so much with the RPM. But the point is, do you see what you call drag on here? That is a totally different charge.
Will this desulfate or
We're desulfation is when your battery is totally useless, and you want to get the sulfation out. Just because this thing is running with the spikes and everything else doesn't mean any desulfation is taking place. That's some conception that started on the internet that I never used the term. I don't worry about whether the battery is desulfating or not. As long as I'm putting the charge back into the battery, I'm not going to worry about sulfation.
Well, this speed took 4 minutes, the other one took 7.
Right.
Well, you have two batteries in the system.
I'll change them if you want me to change them over. Here. like a generator. This is nothing more than a generator. This side goes down, that side goes up. Up, down, up, down, up, down, up, down, up, down, 2 diodes. Right, it's a battery, it's a storage battery. Actually, this curve is quite a bit different in generator mode. Okay, so is it up there? It's almost at 16 volts, so you want to see it go to 16? See, the chemical right now is well, it's having a fit. It's boiling away. It's eating the lead away. You don't need to be there. You just need to be up on that knee up there.
So if you leave it there, you're actually gonna damage your battery.
Oh, yeah. You bet. You're going to boil this away. There's no regulation. There's nothing to protect it.
Do you have a device that can switch those batteries from this one over there?
Well, people that build it, I don't do that. I'm not into that. You guys are into that. To me, I'm proving to you that I'm not going to deplete this front battery. In fact, it's going up. So I don't need to listen to that.
The knee you're talking about is right at the first one.
The knee is right here at 15 volts. See it? Now it can only gain, and it's gaining linearly.
So would you want to stop this at 15 volts?
I would stop this at 15.32 and say, hey, it's charged. Why do I want to burn up the sulfuric acid in the battery? Why do I want to just boil the water away? You don't want to do that. Okay, so we'll stop it, right? Everybody's satisfied. It ran like a generator, except for you. What?
No, I'm satisfied. The estimated amperage over.
I don't go by amps.
No.
Well, I can put it on there if you want me to put it on there.
Just out of curiosity.
Actually, I was going to use the amp meter on the pulse charger, so you could see what's going to happen, because we'll be able to change the pulse charger to do whatever we want, to step it up just like the generator. So see, it can't go any more. That's it, it's shot, it's done. You know, you put any more in that battery, you're doing the same thing that an alarm charger does. 1228, going up. You know why? Do you know why? What's going on with this circuit? No, it's pushing backwards. It's pushing backwards to the primary. From the main coil. The rest is being delivered to the secondary battery. So why am I worried about my primary going down?
Does this only happen in the generator modes?
No, this happens in a lot of different modes. It will happen with a capacitive discharge too.
Okay, but not in the pulse mode.
Under the radiant charge, right, not very much can go back because the pulses are very small little bits of current. This is a lot of current.
You have a diode in that far side there. It's like this diagram. Yeah.
That's exactly what it is.
You have one over there.
Yeah, it's hanging right here. See it? Hanging right there. And you want to know something? It's warm. Well, to push the storage battery like that, there would have to be some current there. Okay, so 28. God, I can't get it to go down, man. It's just, I don't understand what you people built.
I figured out what that diode does. You people have a question as to what does this diode do? If we short this diode out, we're back to the original radiant charger, right?
Yes.
In the original radiant charger, you get pulses going into the battery. You get a rise time here and then a fall.
Right.
A rise and a fall. If this is grounded, the charges are going into the battery and then when the pulse goes down, there's a capacitive pushback. The ions go this way, they jiggle back, they go this way, they jiggle back.
Right.
With this diode, they go forward, and when the pulse goes down, they can't go nowhere. And so that's why that machine runs faster, because he sees a higher impedance, and more energy is being forced into the battery. Is that
Now,
correct?
absolutely, Frank. You could see it. Didn't take you very long. It's taken these people out here 10 years. So, is this what John wanted to build as a little kid?
You know how few 7-year-old kids get what they want when we are.
There's a few in here that had the same idea, that did exactly the same thing, but maybe they didn't have the means to do it. Me, I was kind of lucky. My dad handed us, at 6 years old and 7 years old, the first top hat transistors that they got from Rocketdyne. All right? So, of course, the school thought, you know, these two guys, don't have them ask any questions. Oh, look at that battery. Don't have them ask any questions, because kids at this age don't need to know nothing. So, we're happy. Right, let's pull the amp hour back out. I think I learned how to use this. Let's see where it goes down and settles, though. What do you think would happen? It would just go as far as the machine could push, and the battery would be depleted to the level that the generator could push to, and then if you took the load off, it would rise back up. That's what the ideal generator does.
Okay, so then you could harvest 1 amp.
You could harvest whatever. Actually, I'm not going to even call it that. See, I'm not interested in the amperage until I take it out of the battery.
But it could be used during the charge.
Well, first of all, why even care if the primary's going up? See, look, it's going down because it's not running.
But you started at 12.2 there, I believe.
Yeah. Okay,
That is free.
that is free. Okay, so let's take our 1 amp hour back out, right? And now that you guys showed me how to use a program, you know what? I'm going to spend a lot of time learning it. So now what we want to do is discharge, right? We want to take our voltage, we want to take our 1 amp out, we want to cut off at 10.5, 13 hours, 1 amp. Yeah, okay, sorry. Okay. Okay. Now look at our curve. Running in generator mode, supplying 2 batteries. Say that again. It's not as dense. There isn't a car battery that's out in the parking lot that's as dense as what the first charge was. It's good. I would use this. It's not dead. It hasn't even made 13 volts yet. That's what it says. Or I'm blind. So, but see, it's real important to take this back out to where we had it. Remember? Because what happens with generators and what happens with pulse chargers and what happens with radiant chargers they're different. Generators, if they're a real DC generator with brushes, can desulfate the battery, as you're talking about. If they're this type of generator, they're more like a power supply, a pulsed power supply. And batteries degrade under that. But what I'm saying to you guys is if you need to force a battery up to get it somewhere to get it charging with either pulse or radiant, that's how you do it. Actually, it held a lot more. Ten years ago, right?
With this mode of charging, your battery won't last as long?
I would not, I'd have to run this curve like for 200 cycles.
No, I mean the physical battery wouldn't last.
No, that's what I'm telling you. I'd have to run this curve and this machine that way for 200 cycles. I'm only showing you what I know. You can do what you want to do with it. This is like the third time because I did this. I wanted to show the modes of operation of the machine. So I knew about this a long time ago, and I didn't want to say anything about it because, look, I'm going to let it go out a little bit longer because it's better. So it's a pretty good mode of charging when you can push back to the front at the same time you're charging the Mac. Is it back down where it belongs? Well, if you build the machine and it's all balanced and it's multiples and you can put amperage while you're taking amperage out. No, you want to take it to 15. You got to be above 15 to get the charge into the battery. Yeah, you want to boil it for a little bit, right? And that's dissolving the sulfate off the plates. Okay, so the next thing is comparator. Okay, so the comparator hooks up a little bit different. The machine is across the capacitors. You want to look? I'll hold it up. See, it's across the capacitors, this terminal and this terminal. And then this terminal over here is going to the negative terminal of the battery. So we're just going to put this wire. You want it? And then there's one other little thing. You need to run a positive wire from here to here. Okay, did you see the little spark when I first hooked it up? That's because the capacitor's raised to the battery voltage. All right, so we can go ahead and go, right? Just say start.
John, before you turn it on, would you give us the resting voltage of that battery? To the primary?
Oh, the primary.
Voltage of the primary battery?
12.63.
Perfect. Okay.
All right, first of all, the comparator, can you see it? Flash? There. I don't have a camera, so I can't look at it, but you see the machine is at the same, it stays the same no matter what you do to it. Okay, so, do you see the little wiggles, what it's doing there? Yeah. So, if I say to it, charge a little faster. You can see the flash. It's bang, 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 bang. See it? And as it approaches the battery level, the comparator will want to go faster. And it'll want to go faster and faster and faster and faster. Because it's looking at the battery voltage. Okay, but if I want to see stair steps, this is what I'm going to do.
You'll slow the rate of discharge, Doug?
Oh yeah. You'll slow the rate of discharge so that you get, actually let me put the current meter in line with it. Okay? That will help. So the battery's gonna fall now. And probably invalid test. But you'll get the general idea when you see the pulses of current. So we won't let it do that. We'll just put this in line. Okay. So can everybody see? It's 1 amp pulses. Okay, so let's take it up. See what it's doing?
It goes up and goes back down. And up and
Of course, because there's this rest time.
5 amp volt.
Well, we can make it go higher, but what's the machine doing, right? Went down. It's going to waver around with this. If I make it go faster, it'll change a little bit more.
Okay, so the fact that the primary battery is 12.3 is drawing energy, but it's not as much as the previous.
Right.
It's not charging the primary.
Right, it's not. It's
Drawing
not
less.
charging the primary.
It's just not drawing as fast.
Right. But it's also doing these horrific pulses. Pulse discharge is great for rejuvenating batteries. This also packs a very dense charge. Yeah, like a hammer. So let's slow it down to like 2 amp pulses. Actually speed it up. Actually, there's a 5 amp pulse. Okay. That's like, forget it, the meter isn't fast enough, so it's much more than that. And you can see it's just stepping it, see it? When the chart actually comes out, when it goes up, we'll just leave it there. This is changing.
Hey, John, can you run it in generator mode with the jet pulser?
Yeah. Well, yes, I can. I can make it go really fast. That's one mode that I haven't shown you. But if we put it in generator mode and make it generate to the capacitors, the charge is going to be enormous because it's got current behind it now. See, right now it's in radiant, supplying the capacitors in radiant, and we're asking for 5 amp pulses at about 1.5 seconds. Okay, so if we stop it, you want to put it in generator mode, right, Tom?
Yeah.
Okay.
this is a 4th mode.
Yeah, there's a 4th one. Also, the time is going to increase on the comparator. So it's in generator mode now. And now what I'm going to do is I'm going to increase. I'm going to try to balance it out. It's growling, hear it? So now that's about 3 pulses per second.
On the primary doing.
It should increase though.
No, it's isolated.
There you go.
That's what's going in the battery. Yeah. See here? Okay, now the comparator's stuck in generator mode. See it? It's going real fast. So these are all steps up. And then changing the mode there, you see we changed it, right? And we ran it until the comparator stopped or got too high. In other words, was switching way too fast. All right, and there was almost an amp on the output of the machine directly. All right now it's pulsing at about 1.25 amps in these little kicks.
So it's already flattening at 15 and a half.
Yeah, now watch this curve because this curve's a little bit different at the end. It's where it is. 12:30. We started out at 12:30. But see the little steps? It's kind of hard to see. I can see them with my glasses, but there's little steps in there, see? Oh yeah. The pulses are much faster than what the meter can go. I just put it there because it's like having a crutch. Everybody thinks in the world is current. What does current do? Can I have some more current? Please? It's not charging, there's no current. So now you know what the machine is. You should have no problem remembering this, right? If you have a problem remembering it, there's the 2 DVDs that were made before this that identically show you the same thing. I did it in advance because I knew you wouldn't remember this and you'd go back and it'd be all goofed up. So go look at the DVDs. At least go look. And try to remember this because in certain situations, this could be a lifesaver. On a useless machine that's been sitting in your bench that you said didn't charge the battery.
How do you measure COP if that battery's not going down?
Good question, isn't it? You can tell by this what the COP is. If you take all those curves,
Right?
you can tell that the machine is about 1.2.
Okay.
Because you're not taking this into account right now. See, no matter what I do with this, now I'm adding another load to it, right? And you can see the power on this one's a little bit different because it's in a traction. So it's actually re-gauging. Remember what I said. I'm going to recap this. I don't want to see any neomagnets. Don't ask me anything about neomagnets because I don't want anything to do with them. They're no good for the machine. It's a buzzword, okay? Buy my new Neo magnet. Look, it can pick up 1,500 pounds. Bull. If you're generating energy, then generate it with the ferrite 8s. It's the same effect, except one is going to cost you. And if it gets warm, it's going to cost you more because you're going to have to replace it. The cure temperature of these magnets can take a lot of heat. The cure temperature of the Neo magnet is very low.
So the difference on the end of this curve is that it's flattening.
Right, right. Each one of these charges has its own little characteristic at the end. But the battery is boiling right now. But the generator, see, in the generator mode, it wanted to push it up higher. It wanted to use the full inductance of the coil. And also in this mode, there is no heat. Somebody just come up and feel it so everybody knows. In fact, they're a little cooler. It's the fan that's cooling them, though.
Could you replace the primary battery by a capacitor?
No, you can't do that.
Can do
Who told you that? You read that on the
that?
internet.
No. I'm just asking you.
No, you wouldn't want to do that. But you could have one primary battery and feed the energy.
Thank you.
John, why 7 wires with 7 transistors and not just one thicker wire with 1 transistor?
You can do it either way.
Didn't,
I'm not limiting you. I'm not telling you you can't do it.
is there one?
Frank brought that question up, and he's absolutely right. You can take a bunch of these coils all in one, right? It's just this device then. It's just this device. And you can isolate every one of these. You would only need one diode, right? And a diode back in generator mode, right? And then, but remember the current here. The current, see, people think that when you take coils and you start putting them like resistors, that this decreases and the current goes up. That's very untrue. Right, instantaneous voltage, right, and the current stays the same. So what are they telling you in school? It's just a bunch of crap. They don't want you to do it. They don't want you to find anything. They want you to do what they want you to do.
So you didn't hear what he said, more coils actually bring.
No, what he said was the coils, right? The voltage, the current is not going to increase.
Okay.
You're just going to have a thicker wire, aren't you? But you need to change this device proportionately. This would have to be a really high power NPN transistor. Good luck, because most of them are only 16 amps. Unless you're going to buy a military transistor and ask for, well, the 5885 is 30 amps, but can't take the voltage. 4502 and the MJ802 is 80 volts, but can't take the current.
Put heat sinks on it, whatever you find.
Right, so you could make this. You could make this by paralleling transistors. Yeah, and put a heat sink on it. Well, you wouldn't need any if you're running an attraction, because it doesn't make any difference. They run cold. It doesn't have to force it out past the pole, so the device runs a lot cooler. So see where the curve is?
Why Why do you twist the wires together?
To make sure the coupling's all the same. It's like ellipse almost, but not quite. How far does what drop? Actually, it's not dropping, it's going up. You can do anything you want to do. Those skilled in the art. See, you're making a big mistake. You're making a big mistake when you think that you can keep putting things. You need to study the simplest form of the machine first to understand all these modes of operations, because John typing on YouTube or on some group somewhere is always a distraction. You type something back to somebody else and somebody else types some, and now the question has changed and went over to cat's claws. Nobody that I've ever seen that has been in a group has ever been in focus and never stayed on one subject more than about 5 seconds. So somebody like me, in the beginning of the year, towards this conference, refuses to talk on there. I don't care what they say. After the show, I'll only talk a little bit until the questions get ridiculous. Because I already talked about it. Tom will tell you he runs it. He runs the energy science forum. And the thing about forums is if you have a forum, why not use it? Actually, you're getting more here right now. You're getting more than you would ever get on the forum. And it's on tape. And it's on a DVD set. And your SG machine should run just like this. There's no secret here. 470 ohms, diodes, the resistor instead of the light bulb, same transistor, same circuit, same place, same time, same channel.
How does this compare with the other propulsion mode?
Heat. Heat. The machine becomes more efficient if these do not get hot. And these are not hot. And it's been running a while. What is hot is this. It's warm, but not hot. Yeah, the diode's taking all the current. Mm-hmm.
It needs to be heat.
What, this? It's pretty cool. This is a little warmer. These are cold. Ooh. That's cold. It isn't the first time. Actually, I had one explode the magnets off. I got it going so fast. Just went right through the tape.
What's the PID of the diode?
Oh, that 400 volts. Just some diode that was laying on a bench, and no, excuse me, it's a 1200 volt diode.
Now you regulate the speed of it,
Regulate the speed of what?
the wheel.
By what you decide here. Yeah, the resistors on it regulate the speed. So, does everybody understand what it is now?
If you remove the two fans, do you gain the 2 nanosquirrels you were taking off the fans?
No, it'll just go faster. I'm using the 2 fans for a load. It's driving a load right now and doing the charging. See, the original, you can look at it this way. What toy have you ever had where you could play with it all day long and watch the battery go up that's driving it and recharge the other battery? You have never had that toy. and have mechanical energy. If you gear this down, this probably could be running a propeller in your boat very slowly. And why would you want to go fast anyway? You're on a vacation. Do you have to get there? What?
How do you determine when you hit the sweet spot as far as,
You don't even worry about it.
pardon?
You don't, Jack, you do not worry about it here with this right now. You don't need a sweet spot anymore. It's in attraction. It's not in repulsion. You don't worry about that curve. See, we wanted you to put it in the curve where the least amount of heat was on the transistor, on the groups. But everybody took that and said, blah, 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 and then the next thing you know is there's gurus, and they start their own forums, and they lock you out. Imagine that, they lock the inventor out. They boot you right out. They know more than you. That's why nothing's working.
Does it matter which way the wheel's going?
Doesn't make any difference which way that wheel goes.
Does the power coil lose? Do you have a gain in the inducted or the overall?
Well, first of all, the circuit says it all. What is the circuit? What are you pulling the energy from? What mode is the circuit in? There's a point about inductance. Here's a coil, right? Okay? Are you listening? You asked. Okay. What mode of operation is this transistor in? Well, it's more than pulse.
What it is going right now, it is open circuit because there's no base drive.
Well, we already know that it's a base drive.
Okay, so it's in the mode.
So, if I was looking at it like an amplifier, Frank, what's its flavor?
Well, it is partially linear initially, but then the more current that goes into the base, it needs to saturate. We really want to saturate it, otherwise it will heat up.
That must be saturated.
Right. And then when the magnetic...
Okay, let me change it a little bit, Frank. No, it's in reverse phase. It's in inverted phase, which is very important. Because where is the gain in the circuit?
The HFE of the transistor.
Right? But the gain occurs between the collector,
That's correct, in the collector circuit.
in the collector circuit. So there's a gain here. If the coil was down in the emitter circuit,
Then it has a .999 gain.
right, right. So that's important to understand that it's inverted. So when you look at it, and if you put a PNP there, then it would be on the opposite side.
Can you use FETs on that part?
Use what you want. Those skilled in the art.
Just try.
FETs are a buzzword. In fact, I'm going to end it right now but I'm going to let Frank tell you something, because Frank brought that up. If you're going to use FETs, you better be able to drive them.
If you use a FET, all power FETs have a tremendous gate capacitance, 2,000 pop or so. So what you need to do is to charge that capacitance really hard 5 volts, 10 volts, or whatever. However, when the transistor begins to switch, you get what is known as a Miller effect. It is an amplified capacitance, which is a function of the GM of the transistor, which is the gain of the transistor, FET rather. And so you suddenly find that it's very hard to drive. So with this kind of circuit, that does not have enough power to drive a FET. You would have to add what is known as a FET driver circuit. They're available commercially. And then you would actually do something. But it takes people and engineers skilled in art.
That famous word, Frank, but that's the truth to reality.
For us common guys, it's better to just use a transistor and work with it. However, in higher power modes,
No, Frank. Frank
you can use that.
Frank built a 10 coiler and saw exactly what happened when you couldn't drive it. Okay? So, that's the story of the SG.
I thought it was gonna get easier. It does, they said it takes 2 years, it's like, oh, it's really become lost. The only thing I messaged
Aaron, okay, about what time do you think?
they're helpful.
Finish.